aspirants, welcome to Magic World of Physics. In this video, we're going to discuss about some questions from quantum mechanics which is asked in various exams like GATE, BARC, JUST, DIFFER. Hope this video will be helpful for your coming BARC exam 2026. Without any further delay, let's get started. The first question is, an electron of mass m and charge q is in spin-up state 1, 0 at t is equal to 0. A constant magnetic field applied along y-axis, that is B is equal to B0 j cap. The Hamiltonian H is equal to minus h cut omega sigma y, where sigma y is equal to 0 minus 1, 1, 0. The minimum time after which the electron will be in the spin-down state along x-axis, that is 1 by root 2, 1 minus 1 is dash. Before solving the question, we need to understand the value of Z spin up, Z spin down, X spin up, X spin down, Y spin up, Y spin down. That is, Z spin up is equal to 1, 0, Z spin down is equal to 0, 1, X spin up is equal to 1 by root 2, 1, 1, X spin down is equal to 1 by root 2, 1 minus 1, Y spin up is equal to 1 by root 2, 1 I, y spin down is equal to 1 by root 2 I minus I. Initially the particle is in, it is given that the particle is in 1, 0, that means here the particle is in Z spin up state, and it is given that B is equal to B0 j cap, and it is given that the final state is, that is it is in the x-axis with the value 1 by root 2, 1 minus 1. That means here it is in the x direction with the spin down. So here it is a magnetic field that rotates the vector so that it reaches the final state. So here we need to check the time evolution. So for that, we know that the spin operator changes with rotation. That means u of t is equal to e raised to minus I ht by h cut. Here h is equal to minus h cut omega sigma y. Therefore, this is equal to e raised to minus it by h cut into minus h cut omega sigma y. Therefore, this is equal to e raised to I omega t sigma y. Here we are considering omega t as theta. That is, u of t is equal to e raised to I theta sigma y. So, by the time evolution, we need to check the time evolution, how the initial state is changing with time. Here the initial state is psi of 0. While operating spin operator with this psi of 0, we get the final value. That means we can write psi of t is equal to u of t into psi of 0. So this is equal to e raised to I theta sigma y psi of 0. So this is equal to I cos omega t plus I sin omega t sigma y. Here I is the identity matrix into psi of 0. Here psi of 0 is the initial state. That means here psi of 0 is 1, 0. So we can write it as, this is equal to cos omega t plus I sin omega t into 0 minus I 0 into 1, 0. And this is equal to cos omega t 0 plus I sin omega t 0 I. So this is equal to cos omega t 0 plus 0 minus sin omega t. This is equal to cos omega t minus sin omega t. So this is the value of psi of t. We know that the initial state is psi of 0. After the time t, the final state is psi of t. So here it is mentioned that the final state is x spin down. That means psi of t is equal to x spin down. So substituting these values, we can write it as cos omega t minus sin omega t. That means this is the value of psi of t. And substituting the value of x spin down, we can write it as, this is equal to 1 by root 2 minus 1 by root 2. Comparing both sides, we can write it as cos omega t is equal to 1 by root 2. This implies this is equal to cos pi by 4. And sin omega t is equal to 1 by root 2. This is equal to sin pi by 4. That means omega t is equal to pi by 4. That means t is equal to pi by 4 omega. Next question is, a system of 5 identical particles with mass m and spin 3 by 2 is confined in one-dimensional potential of length L. If the lowest energy of the system is n pi square h cut square by 2 ml square, the value of n in integer is dash. So here energy is E is equal to n square pi square h cut square by 2 ml square, and this is equal to n square E0. And here it is given that the number of particles is 5 and the spin is 3 by 2. Therefore, 2s plus 1, this is equal to 2 into 3 by 2 plus 1, this is equal to 4. That means here we can accommodate 4 particles in one energy level. So that in the first energy level we can accommodate 4 particles, and the next energy level we can accommodate 1 particle. That means total we have accommodated 5 particles. So here the total energy is 4E0 plus. That means in the first energy level, that means E0, there are 4 particles. For each particle the energy is E0, so the total energy is 4E0, and the upper level the energy is 4E0. That means energy is 4E0 plus 4E0, this is equal to 8E0, this is equal to 8 pi square h cut square by 2 ml square. So here the value of n, that is equal to 8. Next question is, a system of 3 non-identical spin-half particles H is equal to A by h cut square into S1 plus S2 into S3. The set of possible eigenvalue of system is dash. So here S1 is equal to 1 by 2, S2 is equal to 1 by 2, S3 is equal to 1 by 2. So S12, this is equal to S1 plus or minus S2. So this is equal to 0 and 1. And here S3 is equal to half. So S is equal to S12 plus or minus S3. So this is equal to 1 by 2 and 3 by 2. Here it is given that H is equal to A by h cut square into S12 S3. We know S square is equal to S12 plus S3 the whole square. So this is equal to S12 square plus S3 square plus 2S12 S3. That is S square minus S12 square minus S3 square by 2 is equal to S12 S3. So the expectation value of H is equal to A by 2 h cut square into S square minus S12 square minus S3 square. So here we need to find the expectation value of S square, S12 square, S3 square. The expectation value of S3 square is equal to h cut square S3 into S3 plus 1. So here we know that S3 is equal to half. So this is equal to half into half plus 1 into h cut square. So this is equal to 3 by 4 h cut square. So similarly, we can find the value of S square and S12 square. So for S is equal to half, S12 is equal to 0, S3 equal to half, we can write E is equal to, that means the expectation value of H. This is equal to A by h cut square into 3 by 4 h cut square minus 0 minus 3 by 4 h cut square, and this is equal to 0. And for the combination, S is equal to half, S12 is equal to 1, S3 is equal to half, we can write E is equal to A by h cut square into 3 by 4 h cut square minus 2 h cut square minus 3 by 4 h cut square, and this is equal to minus A. So the only option that have the energy eigenvalue minus A is option A. So this is the answer. Next question is, if the wave function of the particle trapped in space between x is equal to 0 and x is equal to L is given by psi of x is equal to A sin 2 pi x by L, for which the values of x will have the probability of finding the particle be maximum. So here the probability density, that means I star psi, this is equal to A square sin square 2 pi x by L. So this is equal to 1 because here it is asking about the maximum value of probability. For the maximum value of probability, this is equal to 1. So ignoring the constants A square, we can write it as this is sin square 2 pi x by L is equal to 1. Therefore, sin square n pi by 2 is equal to sin of 2 pi x by L, where n is equal to 1, 3, 5, etc. Therefore, 2 pi x by L is equal to n pi by 2. Therefore, x is equal to nl by 4. Substituting the odd values of n, we can write it as the possible values of x is L by 4, 3L by 4, etc. So here the answer is option D. The next question is, an atomic state of hydrogen is represented by psi is equal to 1 by root 2 1 by A0 the whole raised to 3 by 2 into 1 minus R by A0 into e raised to minus R by 2 A0 cos theta. So find the quantum numbers. The general equation for the value of psi of hydrogen is psi is proportional to e raised to minus R by n A0 cos power L theta e raised to minus Im phi sin power L theta. So comparing this with the equation given in the question, that is psi of r theta phi is equal to 1 by A0 raised to 3 by 2 e raised to minus R by 2 A0 cos theta into 1 minus R by 2 A0 into e raised to I0 phi.
Comparing these two equations, we get L is equal to 1, M is equal to 0 and N is equal to 2. So these are the quantum numbers. The next question is, the radial wave function is R is equal to AR by A into e raised to minus R by 2A. If gamma A is the most probable distance of particle from center, then what is the value of gamma? So the most probable distance is the distance at which the probability density is maximum. So here probability P of R is equal to R square into R square. Here it is given that R is equal to AR by A into e raised to minus R by 2A. So R square is equal to A square R square by A square into e raised to minus 2R by 2A. So this is equal to A square R square by A square e raised to minus R by A. For the most probable distance, dP of R by dr is equal to 0. That is d by dr of r square a square by a square into r square e raised to minus r by a is equal to 0. That is d by dr of r raised to 4 e raised to minus r by a equal to 0. Differentiating this, we can write it as r raised to 4 e raised to minus r by a into minus 1 by a plus e raised to minus r by a into 4 r raised to 3 is equal to 0. R raised to 3 raised to minus r by a into minus r by a plus 4 is equal to 0. That means here r equal to 0 and minus r by a plus 4 is equal to 0. So here r is equal to 4a. And here it is given that r is equal to gamma a. That means gamma is equal to 4. So this is the answer. The next question is, a particle of mass m in an infinite potential well of width a subjected to perturbation v dash is equal to h square by 40 ma square. The first order energy shift for the fourth energy eigenstate due to this perturbation is h square by n ma square. Value of n is dash. So here we need to find the first order energy shift for fourth energy eigenstate. Fourth energy eigenstate means here n is equal to 4. First order energy shift means En1. So this is equal to h dash and this is equal to, here we need to find the range of perturbation. Here the perturbation is from 3a by 4 to a. So here the first order energy shift, that is En1 is equal to the expectation value of h dash and this is equal to integral over 3a by 4 to a psi 4 star v dash psi 4 dx. So this is equal to v dash integral over 3a by 4 to a psi 4 star psi 4 dx. So this is equal to v dash into the probability of 3a by 4 to a range. Here it is given that n is equal to 4. So the number of nodes, that is n minus 1, is equal to 3. So the wave function can be drawn like this and each points can be marked like this, that is 0, a by 8, a by 4, 3a by 8, a by 2, 5a by 8, 3a by 4, 7a by 8, a. And the corresponding psi square, that means the probability, can be drawn like this. So here if we observe, from 3a by 4 to a, the probability is 1 by 4. So that we can write h dash is equal to v dash into 1 by 4. Here it is given that v dash is equal to h square by 40 ma square. So this is equal to 1 by 4 into h square by 40 ma square and this is equal to h square by 160 ma square. And here it is given that the first order energy shift is h square by nma square. Comparing these two, we can write n is equal to 160. The next question is, consider a particle in one-dimensional finite potential well at x is equal to 0 and x is equal to L. What is the first order correction to energy? So here the perturbation is applied between x is equal to 0 and x is equal to L. So here it is a straight line. So the coordinates are 0, 0 and L, V0. So this is a straight line. So we need to consider the equation of the straight line, that is y is equal to mx, that is equal to y2 minus y1 divided by x2 minus x1 into x, and this is equal to v0 minus 0 divided by L minus 0 into x, and this is equal to v0 x by L. So the first order correction E1 is equal to the expectation value of h dash, that is equal to the expectation value of v0 x by L. This is equal to v0 by L into the expectation value of x. So here it is given that the perturbation is from x is equal to 0 to x is equal to L. So here the average value of x is L by 2. Actually this is a proved value, so we need to by heart that from the perturbation from x is equal to 0 to x is equal to L, the expectation value of x is L by 2. So that we can write h dash is equal to v0 by L into L by 2. So this is equal to v0 by 2. The next question is, consider a particle in a 3 different boxes of width L. The potential inside the box vary as shown in the figure. V0 is less than h square pi square by 2m L square. So we need to find the correct order of energy. We know that energy is proportional to area under the curve. So here we are only considering the area under the perturbation. In the first figure, the energy is E1 and the perturbation is from 0 to L by 3, and this is shaded here. In the second figure, the energy is E2 and for third the energy is E3. In all these three figures, the shader portion shows the area under the perturbation. So here when we observe, the area of E2 is greater than E1. So E2 is greater than E1 here. And also when we observe E3 and E1, we understood that E3 is less than E1. So the correct order is E2 greater than E1 greater than E3. Next question is, a hydrogen atom is in the state psi is equal to square root over 8 by 21 psi 200 minus square root over 3 by 7 psi 310 plus square root over 4 by 21 psi 321. If L is in the angular momentum, the average value of L square is dash h cut square. Check whether it is normalized or not. That means we need to take the coefficient and take the square and then add it. If the sum is 1, then it is normalized. That means 8 by 21 plus 3 by 7 plus 4 by 21 is equal to 21 by 21 and this is equal to 1. So it is normalized. So the average value of L square is equal to summation over lambda s ps. So here there are 3 states. That means L square average is equal to lambda 1 p1 plus lambda 2 p2 plus lambda 3 p3. p1 is equal to 8 by 21, p2 is equal to 3 by 7, p3 is equal to 4 by 21. And here lambda is equal to h cut square into L plus 1. In this psi 200 state, n is equal to 2, L is equal to 0 and m is equal to 0. Similarly, we can write the value of n, L, m for psi 310 and psi 321. Substituting these value of L in the lambda, we can find the value of lambda 1, lambda 2 and lambda 3. Therefore, lambda 1 is equal to 0, lambda 2 is equal to 2 h cut square, lambda 3 is equal to 6 h cut square. Substituting these values of lambda 1, lambda 2, lambda 3 and p1, p2, p3, we can write average value of L square is equal to 0 plus 3 by 7 into 2 h cut square plus 6 h cut square into 4 by 21 and this is equal to 2 h cut square. So here the integer before h cut square is 2. So this is the answer.
This is the end of this video. Thanks for watching this channel.